Good morning, all of you. This is Kishore Babu Nampalli, a research scholar from Department of Computer Science and Engineering, Indian Institute of Technology, Roorkee, India. I'm here to present my research paper, the title as an efficient multifunctional deep learning model for effective medical image classification using skin lesion database. Coming to the introduction here, I want to introduce a few keywords based on the title. They are multifunctional model, deep learning model, skin lesion dataset. The multifunctional model means the model which is proposed here is for binary classification, at the same time multi-class classification. The deep learning model, what we used here is deep ensemble learning model. It's designed as a proposed model for classification purpose, that is for binary and multi-class classification. That we'll see in future slides about the proposed model. The skin lesion dataset, it is actually a medical image dataset of skin cancers images from ISIC challenging dataset. The coming to classification, the learning process are divided into several categories. Here we mentioned two main things: supervised learning and unsupervised learning. Under supervised learning, classification and regression, two things are there, and under unsupervised learning, clustering is there. Our role is for classification. The classification is basically a process where computer can analyze an image and identify the class of that particular image. It means it can be defined as also like the probability of an image being part of a particular class. The class may be as a label or an instance or core or animal or building and so on. The classification is divided into two types. One is binary classification and multi-class classification. The dataset here we used, one is for binary classification, one is for multi-class classification. And here the dataset which is used are of skin dataset, means skin cancer images for medical dataset. Extracting and processing the features of these medical images are very challenging and a difficult task because of different properties. As shown in this slide, you can see the figure A, it is having large size, a lesion, and figure B is showing irregular border of a lesion, and figure C, if you see, low contrast surrounding. The image lesion part contrast is almost similar to background part, surrounding part. It is very difficult to detect and to process the features of this type of images especially. And other artifacts, if you see figure D, the hair is there, so we have to apply pre-processing techniques to remove this hair and other artifacts. The one dataset which is used for binary classification is having 400 images. Among these 400 images, 200 images are of type malignant and 200 images are of benign. These are two different types for binary classification. The dataset is divided into 70%, 10% or 20% for training and test and validation dataset. We divided the dataset into trained data, test data and validation data. So is of 70%, 10%, 20%. So here we can see the different types of images, the malignant image, how it looks like, and the same way benign image, how it looks like. Coming to the another data set which is used for multi-class classification, it is having 600 skin lesion images of size 224 by 224 size. So the total images are divided into 8 classes. So basically this data is used for multi-class classification. Here the data is divided into 8 classes. Each class is having 200 images. Here we can see the types of images or classes. Figure A, B, C up to H, 8 images are there. So here we have mentioned each image from each class, so just to identify the different classes. Coming to the main point, the classification can be done using different techniques. One is basic machine learning techniques like SVM, support vector machine, LR, logistic regression, and DT, decision trees, and KN, K nearest neighbors, and RF, random forest, and so on. There are many techniques. In the same way, coming to deep learning architectures, there are many architectures like CNN, RNN, LSTM, and so on. And recently, trend is like no need to train the model, and we will use pre-trained model to get the better results in order to improve the performance of proposed model. So the third one is transfer learning. So here pre-trained model will be used to implement the task. In the same way, next thing is ensemble learning. So if you see here, first one, different classifiers are there. In case of fourth one, we'll combine all these individual classifiers to make a single architecture, and this will give better performance. And here, the deep ensemble learning, it is a proposed idea of our team. It includes the CNN deep learning architecture and the transfer learning and then ensemble learning. So combinedly, we proposed one more very good model, and it gave very good results that we can see in future slides. The deep ensemble learning based classification is shown. The basic architecture, the flow of work, it is shown in this figure. It is divided into different stages. Mainly here we consider two stages. One is feature extraction and pre-processing, and ensemble learning. The feature extraction and pre-processing, here if you see, there are several layers in a deep learning architecture, and several convolution layers are used for feature extraction, and followed by few other layers like max pooling and activation functions. Based on the need, we can modify and the layers, maybe in number of layers and the order of layers, to improve the performance of proposed model. The convolution layers are described with the digital filters and used for image transformation, and the pooling layer is used for dimensional reduction with the help of pixel transformation. These are few pre-processing techniques we can apply. And one more thing is data augmentation is a regularization technique. This is one of the important pre-processing techniques to generate more training data using given data set to reduce the overfitting. So overfitting is a problem. It depends on the data set size and properties of data images. So if we apply data augmentation, this is one technique to reduce the overfitting so that we can improve the performance of proposed model. And data normalization is also one more technique to improve the performance of a model. Data normalization and other transformations, including rotation, changing the contrast, shifting, adjustment of exposure to make it large size of the data set. So suppose given data is small, usually deep learning requires large size data set. So for that we can use this augmentation and these transformation techniques to increase the size of the data set so that deep learning can perform well. The input image is given for feature extraction and pre-processing, and features have been extracted with the help of mobile net pre-trained model and given to the next stage of processing. Here we have used pre-trained model, that is mobile net pre-trained model. With the help of this model, feature extraction and further processing has been done. Coming to the main basic thing is deep learning, deep ensemble learning based classification. Linear classifiers are less versatile because they have a strong bias. Non-linear classifiers have low bias, which makes them more flexible, but they have a high variance, which leads to overfitting. So if bias is low, that is also a problem. If bias is strong, that is also a problem. So here we have to maintain the balance, synchronization among bias values. So as a result, here we proposed very good architecture, that is deep ensemble learning model, that is ensemble learning architecture proposed for achieving low bias and low variance by combining these base models to improve the performance of a model. In this case, the base models are like base classifiers. Logistic regression classifiers we used as a proposed model, as a part of proposed model, and it is implemented with the help of pre-trained models, that is mobile net. The mainly here our idea is logistic regression classifier with mobile net pre-trained model gave very good results compared to other models. So this is a proposed model architecture, proposed idea architecture in the form of diagram. Input data we collected and it is divided into different classes in case of binary classification or multi-class classification. And then coming to next stage, feature extraction and pre-processing. Here we use pre-trained models and we applied feature extraction and then pre-processing, and the data is divided into train and test and validation. And the data after division, data is given to different sub base models, base classifiers as a subdata 1, subdata 2, subdata 3, and the data will be given to classifiers, and then finally the results will be combined based on some criteria. So finally it is called a meta classifier. So finally we will predict the results, that is called as a classification results. So this is a proposed algorithm, how the proposed methodology works. The proposed algorithm here, these are the steps. As we have seen so far the discussion, it is given in the algorithm. And if you see the equation here, a equal to 1 minus x whole power y, x is the accuracy of each base model, y is a number of base models, e is accuracy of ensemble learning. The metrics and evaluation here, the performance metrics what we have used to measure the performance of proposed model, precision, recall, FN score and accuracy. So these are the formulas for precision and recall and FN score and accuracy. These metrics have been used to measure the performance of a proposed model. So this is confusion matrix. It is used to measure the accuracy in terms of like qualitative, quantitatively. There are different ways. This is one way to show the performance of a model. The binary classification, true positive and true negative values. If there are more, then obviously the accuracy is more based on the formula which has been seen in previous slides. In the same way, binary classification and multiple classification, both confusion matrices are given here as an output of a proposed model. The results also we can see here, a proposed model, that is logistic regression classifier with mobile net. It is showing better results, and the results also compared with other models like the exception model, inception resonate model, inception v3 version 3 model, and resonate 50 model. This is for binary classification results analysis. In the same way, the results analysis for multi-class classification, the proposed works results are compared with other models like inception v3, vgz19 and resonate 50. The discussion here, the main thing what I want to mention is the number of classes determines the type of activation function that can be employed. Suppose for binary classification we will use one activation function, that is sigmoid function. For multi-class classification we will use one function, that is softmax function. So in this proposed work for both binary and multi-class classification we use two things. Sigmoid function we used for binary classification, and softmax function we used multi-class classification. So the other results means results from other classifiers also mentioned here and compared with the proposed idea, proposed methodology, and proposed idea gave good results compared to other classifiers results as shown here. I want to conclude and I want to mention a future work here. This paper presents supervised homogeneous ensemble learning that includes an experiment on two datasets. Both are from ISSC challenge dataset. One is for binary classification, one is for multi-classification. The proposed model produces effective results with the performance gain in terms of performance metrics, as we have seen in the previous slides. This approach is more helpful for researchers and clinicians to analyze the skin lesion and for the skin diagnosis. Other optimization and adaptive algorithms we will use These things will be considered further process. At the same time, latest data set can be considered to estimate the performance. So we are planning to extend this classification work to segmentation work. I mean, we will try to propose a new architecture for both classification and segmentation using new optimization adaptive algorithms and latest dataset. These are the references what we consider for our research work, and thank you.